Welcome to the Manufacturing Engineering Media webinar series. Our presentation today is Workstation Cranes in Today's Workplace, Improving Productivity, Quality, and Safety, sponsored by Gorbel Incorporated. Hello, I'm Mike Anderson, a senior editor at ME Media. Before the presentation begins, I'd like to provide some background on what we will be doing today. Our sponsor today is Gorbel Incorporated. Gorbel has over 30 years of experience providing overhead handling solutions to customers in a wide range of industries, including automotive, aerospace, energy, and medical. In a moment, we'll be hearing from our speaker, Gorbel Product Marketing Manager, Rob Baytall. Rob has a wealth of experience in the material handling space. He's well versed in workstation crane technology, intelligent lifting devices, fall protection systems, and other technologies. In Rob's presentation, you will learn, among other things, about the types of workstation cranes available today, how they are being applied in real-world environments, and their safety and productivity benefits. You will be able to ask questions during the presentation using the Q&A box that will appear at the right of the screen. Time permitting, these will be answered following the presentation. If time runs out before we can get to all the questions, we will make sure the answers are emailed to you. If you experience difficulty during the presentation, please let us know via the Q&A app. Also, if you have questions about any other aspects of our webinars, please email me at Manderson, M-A-N-D-E-R-S-O-N, @sme.org. I'll rejoin you after the presentation with a few concluding remarks. And now here's Gorbel's Rob Baytall. Rob?
Thank you, and thank you to the attendees for spending part of your day with us today. As was mentioned during the introduction, the topic today is workstation cranes in today's workplace, improving productivity, quality, and safety. And if I could add one more to that, we are going to look at a few of the ergonomic aspects of workstation cranes and lifting devices as well. For those of you that are not familiar with a workstation crane, we have a shot of it on this slide. Basically a light to medium duty system designed for material handling overhead, and many times built around the exact activity that is being performed in the workplace. So in the presentation today, we'll look at some traditional material handling methods. We'll look at workstation cranes, intelligent lifting devices, and we'll also look at some real-life applications and case studies as well. So there's a lot going on this this traditional lifting screen, but what I wanted to hit on briefly is items that are either used in conjunction with workstation cranes, or items that are used throughout a facility where workstation cranes may be used in their place. Everything you see on here definitely has benefits in the workplace, but many times can be replaced by the use of a workstation crane. In the bottom left-hand corner, we have lift tables. Come in many sizes and varieties. And when workstation cranes are used, and we'll see this in a few of the applications that we look at later on, many times lift tables are used in conjunction just to give a better ergonomic performance throughout the work cell, and where the lifting device on the workstation crane is used, but it is in conjunction with the lift table to keep everything at the perfect height for the work being performed. One of the themes of the presentation is trying to move away from manual material handling. So some of the items on this slide reflect that. The second item from the left, carts or bins, and I'm sure in your work environment these again come in many sizes and shapes, but many times are used as part of a manual transfer process where parts are either in the cart or the bin and move from one location to another throughout the facility, or possibly move back and forth just within the work cell. You see an awful lot of these when parts are involved. And because it is a manual process, one of the things that we try to address whenever there are numerous carts and bins used throughout the work cell is to try to eliminate that manual process as much as possible. The next item on there, the forklift, probably one of the most prominent items in a manufacturing environment, and definitely have their places as far as moving an item from one location to another very efficiently. One of the areas that we run into with forklifts, however, is when they are used to try to perform activities that a forklift really was not built for. And that can be activities such as placing tools into a machine or dies into a machine, or areas where you have a material that can be damaged easily, and the forklift is trying to perform very delicate operations. So we'll look at real-life application where a forklift may not have been the best piece of equipment to use, although it was used throughout the facility. A workstation crane was used for a particular application within the work environment. On the far right side, we have pallet trucks, or hand pallet trucks as they're referred to. And again, whether it be manufacturing, warehousing, the food industry, you see these used throughout facilities as well. But many times in a manufacturing environment, if a pallet truck is used to move items from one work cell to another or throughout a work cell, it can be eliminated by the use of workstation cranes. So it's one of the items we tend to keep an eye on when we visit facilities, is if pallet trucks are used extensively just to move items within a work cell or from one cell located close by to another cell, and workstation crane may be more beneficial. Upper left-hand corner, we have hand chain hoists. And although it may be hard to believe, there's still a number of hand chain hoists used in the marketplace today. The concept and the design really has not changed for many years, and it really relies on the worker to be able to place enough force on the hand chain to lift the item to a certain level as the work is being performed. So again, that's a manual process, and although hand chain hoists at times are used in conjunction with workstation cranes, we do try to move away from the hand chain hoist to something powered, if at all possible. In the middle of the slide, we have overhead traveling cranes, and these are normally larger crane systems that are used throughout the work facility to move heavy-duty items weighing many tons. Again, have benefits really throughout the facility, but one of the areas that we do run into is where a heavy-duty overhead traveling crane is used to try to perform a very delicate operation. And when that's the case, it may be beneficial to take a look at a smaller workstation type crane that can be built right around the work environment and used for that particular application. And then the very last part of the slide, we're looking at the manual transfer, and it does kind of tie into the pallet truck and the cart and the bin. But one of the areas that we look for when discussing the possibility of workstation cranes with firms is just the amount of manual work that is involved with either moving parts to a piece of machinery or moving components throughout a work cell. Sometimes you can't eliminate parts of that transfer process, but many times you can look at how the movements are being made and come up with a solution that is really causes less wear and tear on the body than a manual transfer process. So when we talk about cranes, we really talk about three different styles overall. The I-beam crane is probably the most traditional crane because they've been really used for over 100 years in some cases. And this is where you have a beam that's part of the overhead structure, where a trolley is used to ride along that beam and move usually heavy goods from one location to another, and normally in a straight line. Again, with heavy-duty applications, sometimes this can be very beneficial, but really that beam that's being used was not designed for moving loads on it, really designed as a part of the structure. So although it can be used to move loads, it really wasn't designed for that like the other two that we'll take a look at. For systems that are known as padded track systems, and again, many times these can handle very heavy loads, these are designed to be manufactured and placed into a work environment, normally running along the ceiling height or just below ceiling height. But what sets these apart from the I-beam type cranes is the fact there is a track built right into that beam that the trolley travels in. So you do get a much smoother operation using a patented track system than in the I-beam system, which really was not designed for traveling back and forth. And then the one that we're going to spend most of the time on today is really the enclosed track system that the Workstation Cranes provide. And that's where, if you look at that the solid blue area in the slide, that's really where the trolley slides back and forth throughout the track, provides very smooth operation, and keeps dirt and debris from hindering the movement overall. So all the Workstation Cranes that we'll talk about today feature this enclosed track type system as part of the structure. So when we talk about Workstation Cranes, we'll talk about a few different components that are part of the Workstation Crane. So in this slide, you see the yellow part of the slide, which is really the bridge that we'll talk about throughout the presentation. And that's the part of the Workstation Crane that moves back and forth. So it does move along the runway, which is highlighted on the right-hand side of the drawing, and provides that flexibility so that overhead crane can cover the entire work cell or area where work is being performed. And then some of the other items to point out, we will talk a bit about the trolley saddle height, which is really that area where the lifting mechanism attaches to the trolley that is built into the bridge system. And the goal is to try to keep that trolley saddle height as low as possible to make it much more easy to move the bridge system around. We do point out the trolley on here. We've got a couple different types of trolleys. One is where that lifting attachment, such as a hoist, would be attached. And then on the bridge that runs along the runway, we do have what's known as end trucks to provide the same type of rolling as the hoist that would travel along the bridge. Now this is a typical system that you see here, and this is known as a freestanding system, where it would be built around the work area, and you have the columns and the header to act as support for a system. Again, these are most prevalent in industry today, but there's also systems that are known as ceiling-mounted systems as well, and that eliminates the columns that you see here along with the header, and you use the support of the building to support the Workstation Cranes. And we'll look at one example of that and the reasons that a ceiling-mounted may be preferred over a freestanding system in some cases. So how are Workstation Cranes different from traditional cranes? And as I go through the presentation, this is intended to be an information session, providing you with the basics of Workstation Cranes and lifting devices. When we get into certain parts where we're talking about specifications or capacities, those sorts of things, those are Gorbel specifications, but it does match up closely with what you'll find in the industry from other manufacturers. So I just want to point you out these, as you see capacities, bridge lengths, items like that, it may not match exactly with the remainder of the industry. But one of the things that really sets Workstation Cranes apart is that enclosed rolling surface. Together with the trolley, just provides a very smooth operation, makes it very easy to move that bridge back and forth throughout the work cell and get the lifting device positioned properly so that a straight vertical lift can be used depending on the job requirements. Again, these are really designed for what we call light or medium duty applications from 150 pounds to 4,000 pounds, and that really sets them apart from some of the other types of cranes we looked at earlier that are really built as part of the facility or the patented track style that we talked about. The bridge lengths overall can vary from 4 feet to 34 feet, and these Workstation Cranes are designed to be manually moved. We can put the powered workstation cranes into a facility, but one of the major benefits of using a workstation crane is the fact they are so easy to move manually. So by far, the most preferred style is the manual style of a workstation crane because of those low push-pull forces and the fact it's easier to move. And the last bullet there just highlights that they are 2 to 3 times easier to move than traditional I-beam crane systems. And the reason we put that in there is the fact that when we go into a facility many times, they may have a traditional I-beam crane system that's been in place for a number of years and use it for a variety of applications. But if it is something where the work area has to be either modified on a regular basis or the worker has to move that crane manually throughout the workday, is when we talk at considerable length about the benefits of a workstation crane. So why do companies choose workstation cranes? Again, one of the themes throughout this presentation is the goal of eliminating manual material handling. So I would say in more than 50% of the cases when we visit a facility, that's one of the things that is stressed, the fact that they're looking at different ways that material is moved manually and trying to figure a way to take that wear and tear off the worker throughout the workday. So as part of that, it can increase productivity, especially when a manual system is being used to move items throughout the work cell. And if 2 individuals are required to precisely lift and position a load for the work that's being done, many times using a workstation crane with a lifting device, they can move from 2 workers to 1 worker. Reducing the overall strain on the workers, and again, that's part of getting away from the material, the manual process of lifting, plus the fact that they are trying to move some of those traditional I-beam cranes manually. Much more difficult to move those than it is a workstation crane. The overall emphasis on ergonomics. Again, we're stressing safety as part of the presentation here, but we'll also talk about the ergonomic effect as well, and more companies looking at different ways that they can change work practices to emphasize ergonomics. The changes in work practice and workflow, especially when it comes to companies looking at the lean manufacturing and similar type items, the workstation cranes can be built around that workflow. So many times companies will install a workstation crane, a few years later change that work practice and flow, and may be able to use much of the same components as they do that. Maybe they're changing from more of a line environment to a U-shaped cell or something like that, and the workstation crane can actually be modified easily and reinstalled to meet the requirements of the new work area or the changes in the workflow. One of the major benefits is trying to match the material handling products with the application. And we'll look at the items that are used in conjunction with the workstation crane and talk about some of the benefits of those as well. Because the workstation crane is really one part of the system overall. You have that as the device that is moved directly above to keep that lifting device, normally a powered hoist, vertical above the work that's being performed. But many times you have a third component as well, and that would be the tooling that is used to lift whatever is being worked on. And many times that requires custom tooling depending on the application. So we'll take a glance at the custom tooling later on in the presentation as well. One of the areas, and I mentioned this with the forklifts, the fact that many times companies try to do everything they possibly can with forklifts. Just to get the most use out of them, and the fact that they are used throughout the facility. But many times they're not built for real sensitive type applications, and that's where companies may want to move away from using a forklift to a workstation crane to handle the more sensitive movements. And finally, curve systems are available. Unlike traditional I-beam cranes that run in a straight line, curve systems can be manufactured to meet specific applications. So look at the enclosed track overall. Mentioned earlier that the trolley runs inside the track, and this reduces the concerns about dirt and debris impacting movement. One of the reasons that there's little or no maintenance required with workstation cranes is the fact that the dirt and debris is kept from the rolling surface. So that's probably the major benefit overall of using a workstation crane. The other is the smooth running surface means lower rolling resistance. The special stamped trolleys with the special wheels are designed for the exact taper of the rail. So the trolley matches up exactly to the rail, which many times with a traditional I-beam crane may not be the case, especially because the traditional I-beams are not really designed for material handling. They're really part of the structure. You may have a difficult time choosing a trolley that runs very smoothly on that rail, where with the enclosed track system that is not the case. We do keep the low track weight, the track weight very low. Again, that means less strain on the worker. Very easy to move these systems above and place the lifting device directly above the work application. And for long spans, not many support assemblies are needed because of the lightweight aspect of the track itself. So this can be a benefit as you try to keep work areas clear for other types of workflow that are going on in the same location. So basic specifications, some of these we hit on earlier, but capacities up to 4,000 pounds. The standard bridge length of 34 feet, and the standard runway lengths of up to 124 feet. Again, these are Gore-Bell specifications, but they match up fairly well with the industry standards. So some questions to ask when you're looking at a workstation crane. The first is motorized or manual crane movement needed? I mentioned earlier that for the most part, our cranes are designed to be manually moved. It's one of the major benefits. But especially if you're moving from a traditional I-beam type system that was motorized, your workers may prefer a motorized system when you move to a workstation crane as well. So we can add that feature to the crane. Although we do try to explore all of the manual options first, because that is one of the major benefits of moving to a workstation crane, the fact it's so easy to move. The size of the area you need to cover, and I mentioned earlier that one of the main positives about using a workstation crane, we do try to match up the crane with that exact coverage area needed. So although many cranes are sold directly from a price page or a catalog, most of the time it's a case where someone will come in, take a look at the work area that needs to be covered, and the crane will be developed based on those needs. The bridge length, it goes hand in hand with the coverage area, as does the shape overall of the coverage area. All these things will need to be considered. And again, many times the way this is approached is to have a local dealer, whether it be a crane builder or a systems integrator, someone like that, pick them in and take a look at the work being performed, the exact coverage area needed, and then the crane is basically built based on those requirements. The cycle times really come into play mostly with the type of lifting device that will be used. Many times electric chain hoist is used with this system, and it may be a case that depending on the needs of how often that hoist is going to be used, what type of movement is needed, the speeds at which the work needs to be performed, all these things will come into consideration when you choose the hoist that you want to use with the system. How should the crane be supported? We looked at the freestanding systems, which is the most popular style, but many times companies want to keep that area clear underneath the workstation crane for other types of movement that may be going on, and that's when they move to a ceiling-mounted type system as well. And then overall, the capacity of the crane. This is something that we do provide systems with mixed capacity bridges. So you may have one area of the work cell that needs a 4,000 pound capacity, for example, and maybe there's another area of the cell that's more parts related that is you only need 500 pounds. So we can put a 4,000 pound bridge on one area, a 500 pound bridge on another area, but then we do end up beefing up the entire system to take into consideration the entire working load limit that's needed for the system. One of the items to consider when choosing a crane, a workstation crane, is where that trolley saddle height should be. And as I mentioned, that's basically the area from the floor to where the lifting device fits into the saddle of the trolley. And you do want to keep that as low as possible, if at all possible, only because it makes it much easier to move that crane throughout the work cell. Many companies that are used to using I-beam type cranes, which are many times 30, 40 feet in the air, depending on the where they're being used, they want to keep that workstation crane height as high as possible as well, just because that's what they're used to. But especially if this is non-motorized, we do recommend trying to keep that as low as possible. And as you can see in the drawing here, under 12 feet is really ideal. Many times not practical, and that's where that visit from a local representative or consultant may come into play. And this just shows the reason for that. If you have a lower a trolley saddle, it does make it much easier to not only start the crane, but move the crane overall. You definitely lose control as the system goes up in height. And that's the reason we recommend trying to keep that trolley saddle height as low as possible. So I mentioned earlier that we can provide mixed capacity bridges on the same system. And this gives you an idea why we want to do that, rather than just going with the bridges that would handle the maximum capacity that may be used throughout the work cell. In this case here, if you take a look at the 8-foot bridge, as far as being able to move the bridge around based on the application described here, you're looking at 181 pounds on a 1,000-pound bridge. But if you built the entire system to handle 4,000 pounds on that bridge, you're looking at 72% more force required to move the item around. And that's really, if it is going to be always 1,000 pounds or less, that's one of the reasons we recommend using a bridge really built around the application. Just keep those forces down, and again, keep the wear and tear off the individual workers. So we have performed a few ergonomic studies related to workstation cranes, and we'll actually be updating a few of these during 2014, so we'll have additional results to send out. But on the first one, we were measuring push-pull forces as far as a workstation crane versus an I-beam crane. Push-pull forces were measured for both male and female for traditional I-beam cranes versus the workstation cranes. We determined the gross force required to keep a load in motion while safely performing work at a sustainable rate. And we say safely, that was not exceeding 33% of their work capacity. So, and the work capacity was measured by the heart rate. The rate had to stay within 5 beats per minute of the target. So what we found out was on the push-pull forces that 99% of males could safely move 4,000 pounds with a workstation crane. So just about everyone involved in the study could move that 4,000 pounds with a workstation crane. But only 10% could safely handle the 4,000 pounds on an I-beam crane. So that reflects overall just the main difference between using that workstation crane and being able to effectively move that throughout the work area. And 65% of the females could safely move 3,000 pounds of the workstation crane. And although it's not on the slide here, less than 10% of the females could safely handle 3,000 pounds with an I-beam crane. So when we looked at the initial forces involved with this, the workstation crane, there was about a third of the force that was needed compared to an I-beam crane. And the sustained forces for males, it was 1/8 of the effort required to move the workstation cranes, and for females it was 1/4 of the effort. So no real comparison, and again, the reason that we included this as part of the study is that we had a number of firms that had traditional I-beam cranes throughout the facility, and we're not matching up the crane with the exact job requirements. But by moving to a workstation crane, this kind of showed the benefits of doing so as far as the effect on the individual workers. And then on the second study, the productivity study, we measured the amount of work that an individual can accomplish during a typical day using a workstation crane versus an I-beam crane. So you see that the males were able to increase productivity by an average of 27%, females by 28%, and the work intensity had to remain steady overall during this, and the way that was measured was through a heartbeat monitor in all participants. So the details of the study, they had to move a 500-pound load, and the subjects averaged 7.5 additional work cycles with a workstation crane over a 10-minute period. So if you take that 10 minutes and translate that to an hour, they would have 45 additional work cycles. And again, this was just really trying to highlight that difference between using a workstation crane versus an I-beam crane in terms of productivity. These bullets I just covered as we went through the study. So what's used in conjunction with a workstation crane? I mentioned earlier that the workstation crane is really one component of the system. So many times a powered hoist will be used in conjunction, and that's what you see on the left-hand side here. Traditionally, that has either been a single-speed or a two-speed type system. You see more hoists nowadays with variable frequency drives, or VFDs, built into them. That's really designed to give the operator much more control over the lift versus a single-speed or two-speed lift where the lifts are determined by the manufacturer. So variable frequency drives on hoists are much more prevalent today. The second photograph shows an air hoist, or something similar to that would be an air balancer, and that's designed, especially in the balancer realm, to give much more control to the worker as far as being able to place a part, say, into a piece of machinery, something along those lines. It does have what's known as a float mechanism built into it, which allows the part to be floating from the device, and the individual worker guides it into the piece of machinery. So that we do see a lot of that in work cell applications as well. And on the right-hand side, this is we don't see nearly as much of this as we have in the past, and that's where a hand chain hoist is used for the lift. And that the real reason for that is a lot of times when somebody's looking at a workstation crane, they're buying it for safety or ergonomic reasons, and by adding a hand chain hoist to it, you're almost defeating the purpose, because you're still asking that individual worker to make the manual lift by using a product like that. So then the third part of the system is really what is attached to that part that's being lifted. At times, the part is connected directly to the hoist, so there's not a need for a third part of the system. But many companies need to match up with what they're lifting with a particular, what they call below-the-hook devices. And this just gives an example of some of the ones that are available. You have plate clamps to lift, in this case, steel plate. You have tongs to lift component parts, vacuum suction cups to lift different pieces. You have slings, whether it be chain as shown here, wire rope, synthetics that can be used as part of the system. And the last item you see on there is a bag lifter, and that's really a case where that tooling device is built specifically for the application, in this case a large bag. So a number of different items to consider when completing the system, but the main three components are the workstation crane, the lifting device, and then what we call below the hook devices or tooling devices to attach to the load. So we'll talk about a few real-life applications where workstation cranes solved a particular problem. On this slide here, on the right-hand side, you see a traditional I-beam crane system. They run throughout the plant, and they do use that to move items regularly. But in this particular application, it was not suitable because of how delicate the need was and how lightweight the load. What you see here are machines that produce small links or chains, and what is done is you see the buckets that are on the ground in the work area. These buckets are filled up as part of the work process and just moved from the machine to the area in the outside the work cell where they can be picked up and taken to another portion of the plant. What was happening was over the years the company had many more female workers joining the workforce, and as a result they were having much more difficulty moving those 85-pound buckets from the machines just a few feet to have them picked up and taken to another part of the facility. So the answer was to install workstation cranes throughout the work area along with air hoists, and now the buckets are moved with that system in place and taking the strain off the workers of moving that 85-pound bucket a few feet. This next one is one where an operation, a two-person operation, actually moved to a one-person operation throughout the work cell. And in this case, cylinders had to be placed in castings with very little tolerance overall. And what was happening is one individual would lift the cylinder, it would drop it into the casting, but as the second person was holding the casting, one would guide it into the system, and they were having tremendous problems with pinch points because there just wasn't a whole lot of room there between the cylinder and the casting. And so what they went with in this case was a workstation crane with electric hoist. Allows the process to be handled by one worker who lifts the cylinder and is able to guide it into the casting for the final operation. So in this case, eliminating a worker who can work another part of the plant, or they can just increase productivity by having two workers, as it looks like in the photograph here, working on the same application. This one here, I mentioned that we do have numerous systems that where a lift table is used in conjunction with a workstation crane. And this one here, it's actually picking up sheets of metal using a special tooling at the bottom of the hoist. And in the past, this was a totally manual operation. The lift table was in place, but you can see all the carts that are around, and those were used in the past to manually move those pieces of sheet throughout the work area. They have been able to eliminate some of the manual process with the workstation crane and hoist, and especially with the tooling that is part of the system as well. So again, in a lot of cases we do move away from carts. In this case, they're still using the carts, but not nearly as much as they were before going to this process. And the final one here, this is one, again, that was a manual process in the past, moved to an automated process with electric chain hoists. This just goes to show you the ceiling-mounted system versus the floor-mounted system. They have quite a bit of machinery and other devices in the work area here, and just didn't think it was feasible to use a freestanding system, so moved to a ceiling-mounted system just to give them that freedom to move about underneath the workstation crane. So one case study that we have was a stone fabricator, and I mentioned one of the things we run into is the use of forklifts to try to perform operations throughout the work cell. In this case, a fork truck was used to move granite slabs into a saw room, and then the pieces were manually lifted into the saw. After they were sawed, they were manually lifted again and moved to another station. The difficulty was that the fork truck wasn't able to handle delicate loads with care and precision, and the potential for damage to the expensive piece of granite was too high. Also, along with that, it was very, very demanding on the workers to move the slabs from the fork truck to each station using a manual process. So in this particular case, the company went with a freestanding workstation crane, a 1-ton electric chain hoist. And the reason that they chose the workstation crane with the electric chain hoist was that the combination made moving the large piece of granite from station to station much easier and much more efficient than the fork truck. But also, it eliminated that product damage that they were having when trying to force the fork truck into an application it really wasn't designed for. And then it also helped to improve the safety because the manual lifting was virtually eliminated. So just one example of a company that tried to use a forklift probably for a little bit more than it was suitable for, and the answer was a workstation crane and electric chain hoist. So in the final few minutes of the presentation, we'll talk about one other lifting device, and that's what's known as an intelligent lifting device, or an ILD. You may also hear these referred to as intelligent assist devices. But what they are is something that to the naked eye almost looks like a hoist, but it really is designed to act like the human body and perform much of the operation where the operator only acts as a guide throughout the process. So on the left-hand side of the screen, the first shot is of the unit itself. The second shot is of the programmable control handle that's part of the system. And the third photograph shows how this can be built into an application as well. So intelligent lifting devices, again, designed to fit the void between traditional lifting devices and robotic solutions. It uses a servo-controlled type mechanism that fights inertia during fast movements, but also allows for precision lifting in placing applications. Very fast capabilities up to 275 feet per minute, and capacities up to 1,320 pounds. So it doesn't cover the range of, say, an electric chain hoist, but for speed and precision, we see more of these intelligent lifting devices used in the marketplace today. I mentioned that it mimics the human motion, where the operator really acts as a guide during the lifting process. The float mode is really what's used for the precision placement. You're able to place the unit in float mode where whatever you're lifting is basically suspended during the area that you set, and then the operator uses that float mode to place the piece of equipment into whatever is being worked on. That combined with the virtual limits is what really makes these intelligent lifting devices very popular. The virtual limits take that ergonomic aspect that I spoke about earlier into consideration, where depending on the work being performed, limits can be set that will allow whatever is lifted to only be lowered or raised to a certain level. And we've seen applications where that range is very small, say from waist level to shoulder level. That's all the more the worker's allowed to lift that component. Otherwise, they are outside the ergonomic guidelines set by the company. So that really comes into play when these units are looked at from an ergonomic perspective. Standard intelligence features, they do come with a number of those types of features built in, but one of the other areas that the users like is the ability to customize that software based on the job requirements being performed. So that flexibility is very important and something that is really not available through standard powered lifting devices. The part of the continuous ergonomic benefits is the fact that the handle does swivel without damaging any electrical conductors, the coil cord, or an optional air coil. So that swivel mechanism, again, allows the worker to use the unit without the unit kind of fighting back versus the worker, which can happen depending on the tooling that's used with a traditional lifting device. I mentioned they can also be built into systems, more or less jib type systems, where you have a freestanding one shown here with a 330-pound capacity, an underarm model up to 165-pound capacity. And I would say that sweet spot for intelligent lifting devices is probably that 85 to 120-pound range, where the component does not weigh a whole lot, but either needs to be lifted continuously throughout the day, or you need that precision to spot that component throughout the work that's being performed. Numerous handle options available as well, either remote handle operations or pendant control, much like you see on the left-hand side there, that is used in similar ones used in traditional hoists. Or the most popular one is where you have the control unit built right into that handle and all one piece and very easy to program and use and view the program that you're in. Many times these are used with custom tooling, whether it be vacuum lifts or something similar, and many of your integrators can look at exactly what you're lifting and provide a solution that is supplied with that intelligent lifting device to meet the needs of the job. So of all the items that we offer, at least, this one has the most custom type work from an end tooling perspective. Okay, I mentioned earlier that we had some ergonomic studies using our workstation cranes, but we also have had some regarding our intelligent lifting devices, and also these ones will be updated in 2014 as well. But I mentioned about the fact we try to move away from manual material handling as much as possible with about everything that we discuss at Gorbel. And this first one just gives you an indication of the difference between using an intelligent lifting device, which is the G-force you see on the left-hand side of the slide, and all the way to the right-hand side you see the same process manually. And in this case, the subjects were required to lift a 45-pound weight from one position to a position 3 feet away, as many times as they could during a 10-minute period. Subjects wore heart monitors to ensure that they stayed within 45 to 55% of their maximum heart rate. So you can see that the intelligent lifting device outperformed other lifting devices, but also what should be noted here is when the subjects were asked to do the same task manually, they could not even complete the 10 minutes of work and still maintain a safe heart rate. So again, when we're talking about trying to move from manual processes to more automated processes, this showcases. So you can use any of the items on here and outperform the manual side, as far as keeping your workers safe and looking at the ergonomic aspects of the move. And then on a second study, the workers had to move the same 45 pounds and place it on a table 3 feet away, and there was a force plate under the table that measured the force at the impact. What happened in this case, as you can see, the intelligent lifting device on the left-hand side outperformed all the other types of movement. But it's also interesting to note on the far right-hand side, manually moving that 45-pound weight 3 feet and placing it on a table, the forces were higher than a couple of the automated systems. And you would think moving something manually would give you much more control, but because of the weight, 45 pounds, not necessarily that easy to handle, it was difficult for the workers to place that on the table without causing considerable force. And the other item on this slide that I wanted to point out was the variable frequency chain hoist, which I mentioned that's really a trend in the industry with more and more firms going to what's known as a VFD drive, which gives the worker more control, at least on paper, as to how they can move the load, because you're not it's not determined by the manufacturer, it's really determined by the force that the individual worker applies to the push button station of the hoist. But in this case, the forces from a variable frequency control hoist were much higher than any other of the other lifting devices that are out there. And the reason for that, I believe, is it just takes a long time to get used to that VFD as far as that touch point. It can be very, especially if you're used to using a single speed hoist, which really doesn't vary once that button is pushed, going to a variable frequency chain hoist where it is very sensitive to that button being pushed, takes a long time to get used to it. And that's probably the reason that there was much more force applied to the load in this study. Okay, we have a couple examples here as well. We have an example where they were loading and unloading machine centers with an intelligent lifting device, and it really reduced the operator fatigue and eliminated the product damage as well. And I mentioned the float mode, which is a big part of these ILD devices. In this case, the device is kept in that float mode with a range that it will move, so that the worker really just acts as a positioner, not necessarily worried about the lift overall, but as a guide with very basic tooling and easy operation overall. So again, that float mode really comes into play in a lot of different applications where precise positioning is needed. This is a metal fabrication example where they used an intelligent lifting device to make bends on a press brake. And as with one of the other examples we looked at, in this case, it allowed a two-person operation to be done by one worker and ensured product quality overall. They used a remote-mounted handle for this particular application. And again, the float mode was used to insert the sheet into the press brake, and it supported the sheet, so there wasn't any back bending, which was happening in the past. So this happens to have magnetic tooling with a pneumatic release attached to it, but there were many benefits all around by moving to an ILD for this particular application. And we have one last case study to look at, and this is where they were finishing machining on cast parts with a maximum load of 42 pounds. In the process, the cast pieces were loaded into a machining center for finishing, and once they come out of that center, they're placed on a bench for inspection. One of the challenges was that the slow, precise motion was critical so that they didn't experience product damage during the process. Why change? They were having issues with back strain due to the operators having to bend over the machining center to place the part on manually. So that really is what drove that initial call, the fact that so many of the workers were having back strain issues. So they were looking for something that was easy and safe for operators to use to lift, and something that would not cause damage to the machine surfaces. So they looked at an air balancer, number one. Air balancer does have a float mode built in, but it would eliminate the back strain, but overall was not precise enough because air balancers are not programmable, so that they did not get that very precise movement that they get with an ILD. Plus, with an air balancer, one thing that can happen is once you take the load off the balancer if the operator is not careful, the hook can basically fly back up towards the unit itself, and it can be a very dangerous situation. In this case, they actually did try an air balancer before choosing the intelligent lifting device, and had an injury due to that flying hook. So that was one of the reasons the main reason that they decided against using the air balancer continuously for the operation. A power chain hoist was also looked at, and again there was no back strain involved with the chain hoist, lower price, but still not precise enough for the application. And the jogging of the chain hoist can cause damage not only to the hoist itself, but also possibly with what is being lifted. And when I say jogging, that refers to continuously hitting those up and down buttons on a hoist to try and get the positioning and the speed just right. It does cause damage to the controls of the hoist if you do that too often, and because it's not really designed for that kind of a precision type of lift, it can cause product damage as well. So they also looked at the intelligent lifting device, and it did allow for that slow precision motion, and which meant no damage to the part, and it eliminated the back strain as well. But one of the negatives was that it was more expensive than anything else they looked at. So overall, what did they decide? They did, in this case, because of some of the issues that I raised earlier, they decided to go with a crane intelligent lifting device for tooling and install, or crane intelligent lifting device with a price of $15,700 for everything, including the tooling and install. Operators took to it right away with minimal training, and now any employee can perform the operation within the plant. Yeah, I think this was covered in the previous slides, so I won't talk about that one. As final points of some of the things that we talked about today. One is that there's numerous options that exist today to get the superior safety, ergonomic, and productivity benefits. The Workstation Crane, we spent most of the time on that just because moving, especially from a traditional I-beam crane to a Workstation Crane, does have numerous benefits overall. And the fact, if you're trying to match up the lifting device and the crane to the job, the Workstation Crane, because of the flexibility involved, can be ideal for matching up those particular applications. Overall, it does minimize stress in the body throughout the entire process. Whether you're using a powered hoist with it, an intelligent lifting device that we talked about, by moving from a traditional I-beam crane to a Workstation Crane, especially if workers are required to move that I-beam crane manually, it really does eliminate a lot of that stress on the body, and we talked about the ergonomic studies that prove that out. The other item is, especially from moving from a traditional crane to a Workstation Crane, training will be a key, because it will involve changing work practices. But more importantly, as you're moving from manual processes, which may be a case with, like some companies say, well, we've always done it this way, and it's a manual process, it may take a while for workers to actually adjust to the process, and training will be key in that regard. So that's a wrap of the presentation. I'm not sure, because of the time, if we actually are going to have time for questions on this one. If you did send questions in, we will respond to all the questions that we receive via email, since we did run over just a bit in the time frame we were anticipating.
Yeah. Okay, Rob. Well, we're going to be able to answer some questions.
Okay.
We're running a little long, so we'll get to at least a couple of them. And remember that if you submitted a question, we'll make sure that you do get an answer by email. So let's start with one that came in early, which is, what is the typical lead time for a workstation crane?
Well, one of the things that we're able to do, at least at Gore Bell, is send these out under a quick ship program, where if it is a typical application, we do have a 5-day lead time on our crane. So if you do run into a situation where you would need something quickly because of maybe a line changed and the material handling part of it was not necessarily anticipated, Gore Bell is known for sending these out in a 5-day time period. I did mention earlier that many times we have to kind of build the crane around the specific application. So if it is out of the ordinary, rather than one of our, I'll call them off-the-shelf type systems, it could be a little longer than that. But typically, we're able to get most of the cranes out the door within 5 days.
Okay, and here's another one. Do users typically install their own workstation cranes, or do you guys do it?
One of the benefits of a workstation crane is the fact that it is very easy to install, but at the same time, we recommend relying on your local dealer for the install, only because they do this for a living. So although we do stress the fact that, especially compared to other types of cranes, workstation cranes are much easier to install, we do suggest relying on your local representative to perform that initial install at least. And many times the price of the crane will include the install price as well. So that's really our recommendation, although we don't consider these to be complicated systems to set up.
Okay, and here's another one that came in. Is the workstation crane suitable for a machine shop raw material area with vertical access to metal rounds and bars?
It should be. What we would have to do overall is just determine by looking at that setup overall which type I think would be best considered for that application. Because I know at times that can get very crowded in that type of situation. So it may be a case in there we may be able to go with some sort of ceiling-mounted system, or some sort of special jib type system, which we didn't necessarily cover today, that can be mounted to walls for that particular application. So it is possible, but I think in that case we probably would have to look at the exact work area to make that final determination.
Okay, and this will be our last question live anyway. Someone asked as a follow-up to that previous question, are you able to install in Europe?
We do have dealers in Europe. Yes, we do. I don't. It depends on what part of Europe that the install would take place, but we do sell globally, and so we would have someone in Europe that could do an install. Really depends on the exact area in Europe as to who we would recommend, though.
Okay. Well, we've gone about an hour and 5 minutes so far, so I think at this point we'll say if your question hasn't been addressed yet, then please look for a response to it by email. And as Rob has shown, understanding overhead cranes and material handling can improve your production and lead the way to a better bottom line. SME and Manufacturing Engineering Media has a host of ways by which you can keep abreast of the latest in material handling technology. For instance, SME's automated manufacturing and assembly community features member discussions, news briefs, and other community resources. Our August IMTS special issue will include a show preview on quality assurance. The Shop Solutions section of Manufacturing Engineering magazine regularly looked at material handling with real-world case studies. ME Media's monthly Lean Directions and Quality in Manufacturing e-newsletters look at material handling and safety issues from the process improvement and quality perspectives, respectively. And watch for upcoming SME events such as Rapid Additive Manufacturing Solutions and the Big M event, co-located in Detroit on June 10th through 12th, and FabTech, November 11th through 13th in Atlanta, Georgia. And that's all the time we have. So thanks for joining us for this Manufacturing Engineering Media webinar. We hope you found it informative.